This is the second video for section 2.1 of Pre-Calc 11. In the first video, we went over how to draw angles in standard position. This video is going to build on that, and we're going to look at standard position in a slightly different way. So to kick things off, let's just quickly recap what that meant in the last video. So if we draw 160 degrees in standard position, remember, when you're drawing in standard position, that means you're drawing things on the XY plane, right? Your Cartesian coordinate plane. So if we sketch out an angle here, you're going to start with your initial arm, which is going to be on the positive x-axis. Your vertex has to be at the origin, right? So remember, your corner of your angle should be right here. And then your terminal arm is going to go wherever your angle is. So remember, positive is counterclockwise, so that's this direction. 160 degrees is going to be in quadrant 2, close to 180, but not quite there. So maybe somewhere around here. Again, I'm not too fussed on the specifics. So this looks approximately like 160 degrees. So that was last video. This video, we're going to be focusing more on this angle over here. So this one that I'm going to highlight in green. So what about this angle? That angle is going to be pretty important for a few different things. And it is called, which you might have been able to guess from the title, the reference angle. And so the reference angle is a very specific angle that has a very specific property in connection to any given angle. To denote it, so we use theta for angles, right? So instead of theta, we're going to call the reference angle theta r. And so what the reference angle is, it's the angle between your terminal arm, right? So wherever your angle stops, and the closest part has to be the closest part of the x-axis. And this is something that gets messed up constantly. So it has to be the x-axis. I cannot emphasize that enough. Never the y-axis, always the x-axis. So a couple of things about that. Since it's always going to be going to the closest part of the x-axis, and you're never particularly far from the x-axis, the reference angle is always going to be acute, which means less than 90 degrees. Right, so you're never going to get a reference angle of, say, 110 or something. And we don't care about direction when it comes to the reference angle, so it's always positive. So even if it's going clockwise, we don't care. The reference angle is always just going to be positive. Okay, so let's try to work with this. We're not going to do a whole bunch with the reference angles in this video. We're going to see them pop up quite consistently throughout the next few parts of the chapter. But today we're just kind of establishing what they are and how to get them. So let's figure out the reference angle for an angle of, we'll go with 120 degrees. I'm going to kind of break this down way more than it would necessarily need to be broken down. This is a question you could answer in about 5 seconds, but just to kind of really show you how this works. So first thing we want to do, since we're just starting out, is let's draw our angle. So again, that's really not actually necessary for this, but just because it's our first time. So we got our initial arm where it belongs. 120 degrees is going to be in quadrant 2 again, but it's going to be closer to 90 than it's going to be to 180. So 120 we could maybe put somewhere around there, give or take. So our reference angle is going to be from our terminal arm, right? So terminal arm to the closest part of the x-axis. So we're not going to go over here because that's not the closest part of the x-axis. We're not going to go to there because that's the y-axis. So we have to go down to the x-axis, and that gets me my reference angle. So that's step 2, is just to draw the reference angle. And then step 3, the only step that you actually really need to do, is to calculate your reference angle. And you're always going to do that by subtracting. So the reference angle is essentially a distance. It's how far is your terminal arm from the x-axis. And to find a difference, well, we always subtract. So we're going to do theta r is 180 degrees minus 120 degrees. So it's the part of the x-axis that we went to, right? So this was 180 minus where our terminal arm was, which was at 120. And so we subtract those two things, and we end up with our reference angle of 60 degrees. So on the last one that we did, way up here, right? So that was 160. So if we do 180 minus 160, we would have ended up with a reference angle of 20 degrees. So I'm going to throw a few angles at you, and we're just going to talk about how to get their reference angles. So we're going to determine theta r for the following. I am going to sketch these out just because I do want to help visualize how these things work and kind of call out some places that people do tend to mess up. But again, if you just were given this question with no other prompting, you could definitely get this by just subtracting straight up. So I'm going to start right now just by drawing all 4 angles. So once I've got those down, we'll talk about what the actual reference angles are. All right, so our first angle is 40 degrees. Right, so that's going to be in quadrant 1, and it's pretty close to half, right? So half is 45. So this is just a little bit smaller, so something like this. And so that is 40 degrees. Our second angle is 100. So that's going to be in quadrant 2, but that's going to be pretty close up against the axis, right? So 100 is pretty close to 90. We'll say maybe somewhere around there. 310, that's going to be in quadrant 4. And that's also going to be pretty close to the middle, but a little bit less. Right, so this is 315, so 310 should be just a smidge off of that. And then our last one of 230 degrees, that's going to be in quadrant 3. And it's also pretty close to half, just a little bit off. So there we go. We've got our reference angles, or our original angles rather. So this one is 310, and this one is 230. So to get our reference angle, it's always just going to be your terminal arm and the closest part of the x-axis, and it's going to be a subtraction. So if we look at our quadrant 1 angle, right, that's our terminal arm. The closest part of the x-axis is actually just where we started. So if we subtract that, really what we're doing is just 40 minus 0, not 360 because we haven't gone all the way around. And so in the first quadrant, your angle and your reference angle are actually always just going to be the same. For quadrant 2, we've already seen that a couple of times. Right, so we're working with 180 and 100 here. So that's going to be 180 minus 100. So that's going to be a reference angle of 80 degrees. And so this was one that people are going to be tempted to go to the y-axis because the y-axis is right there, right? So you got to remember to go to the x-axis every time. So for quadrant 3, we've got our terminal arm at 310 degrees. We've got the closest part of the x-axis, which looks like it's the initial arm. But remember, we're not kind of going all the way back around this way. We're just doing the closest distance here. So what we're actually subtracting this time isn't going to be 0 like we did in quadrant 1. It's going to be 360 minus that 310 we ended up at, which is going to be 50 degrees. And then our quadrant 3 angle, terminal arm, x-axis, also one that people are going to tend to mix up. I don't know why, but quadrant 3 especially, people tend to want to go to the y-axis. So remember, we want the x-axis. So we're going to do 230 minus 180, which is 50. So a common question is like, how do I know which one to subtract? It's always just the bigger angle minus the smaller angle. Right, so you're just going from however furthest kind of counterclockwise minus however further back you go. And so you're always just kind of subtracting those two things. All right, so let's see if you can go the other way. And we're going to try to draw 4 angles that have the same reference angle. So 4 angles with a reference angle of 30 degrees. And so we're going to need a grid to work with here. Our initial arm for all of our angles, no matter what, is going to be same place it always is. And so if I want reference angles of 30, that means from our x-axis, we're going to be going for a 30-degree angle. Now that's going to look, something like this roughly. And so this is my reference angle. This is theta r, which is 30 degrees. The nice thing about quadrant 1 is that my angle and my reference angle are just the same. So this is also 30 degrees. So our angle in quadrant 1 is just 30. In quadrant 2, we're going to have something that looks like this. So this is 30 degrees, right? This is my reference angle. But that's not the angle I want. The angle I want is the angle that has that reference angle, which is this angle. So this, if we're in quadrant 2, we're going from 180 backwards 30. So that's going to put me at 180 minus 30, which is 150 degrees. So that's my second one, right? We've got 30, we've got 150. In quadrant 3, so again, I want that reference angle of 30 degrees. It's going to look something like this, right? So 30 degrees. And notice how those two lines, so these two here, have lined up with each other because they have the same sort of reference angle. They're making the same angle with the axis, so they should match up with each other. And so same idea. We're going to start at the initial arm. We're going to go all the way around to there. And so this is one where people do get a little bit messed up because we're so used to doing subtraction here. But what we're doing is we're starting at 180 degrees, and then we're going further by 30 degrees. So you're not actually going to subtract here, you're going to add. So we do 180 plus 30, which is going to get us 210 degrees. And then in quadrant 4, same idea. Here's our 30-degree reference angle, and we're going all the way around this circle to land here. And so our angle in quadrant 4, we're starting at 360, right, which is here, and then we're going backwards 30 to our terminal arm. So it's going to be 360 minus 30 is 330 degrees. And so those 4 angles, 30, 150, 210, and 330, are my 4 angles that have reference angles of 30 degrees. And so the reason that we care about reference angles, go ahead and grab out a calculator real quick, so a scientific calculator. And what I'd like you to do is I'd like you to take that calculator and I'd like you to plug in the following: sine of 30, sine of 150, sine of 210, and sine of 330. So those 4 angles we just found that all had the same reference angle, figure out what the sine ratio for each of them is, and then we'll talk about what that gets you. So when you plug them in, you should have gotten for each of them 0.5, 0.5 for 30 and 150, and then for 210 and 330, you would have gotten negative 0.5 and negative 0.5. And so that process is actually going to hold true no matter what. So if you tried it with cosine and tangent, you'd still end up getting the same thing for everything, with one small difference of maybe positives or negatives. And that's always going to be true for reference angles, and that's why we care about reference angles so much. So angles and their reference angle, or angles with the same reference angle. So here, every angle with a reference angle of 30 degrees, which itself includes 30 degrees, will always have the same trig ratios, no matter what, with the exception of maybe the plus or the minus. And that will depend sort of on which ratio you're working with and which angle you're working with. So in this case, all of those sine ratios for each of these things all ended up being 0.5. They're not always going to be nice numbers, right? So if you did cosine or tangent, you'll probably end up getting some sort of decimal. But you're still going to get the same decimal for everything. And so we're going to use that fact about reference angles to do a whole bunch of stuff in this chapter. So that wraps up this video. So definitely make sure you've got a real handle on the reference angles before you keep going, because we're going to need them a lot. And once you're ready, we're actually going to step out of 2.1 for a sec. So there is going to be one more video on 2.1, which is going to be 2.1.3. And you could go into it now, but I do actually recommend doing 2.2.1 before you do 2.1.3. So go on to that video, and then you'll come back to 2.1 in a bit.